Hi, this is Abhijit. I have created this small simulation software which is based on mathematician John Horton Conway's Game of Life concept from the 1970s. In this concept, there is a infinite grid of cells. Each cell can be living or dead. Now, as the simulation proceeds, each cell becomes living or dead in each generation based on some constraints. If a cell has less than 2 living cells in its surrounding, it dies due to loneliness. On the other hand, if there are more than 3 living cells in its surrounding, it dies due to overcrowding. If it has exactly 2 living cells in its surrounding, it stays the same in the next generation, while if there are exactly 3 living cells, it becomes living in the next generation. Initially, we can randomly make some cells living. And when we run it, it can give rise to very complicated patterns and some simple ones. Now, let's have a look at the controls. They are situated here at the bottom. Here, you can customize some properties like number of rows, number of columns, cell side length in pixels, and delay per cycle of the simulation in seconds. And you can apply. Here is a play pause button to run the simulation automatically. Here it's the reset button, help, about, and exit. And here is the simulation canvas. Press the left mouse button and drag over the cells you want to make alive. Similarly, to erase the cells, press the right mouse button and drag over the cells you want to erase or make them non-living. Then you can run the simulation manually by using the scroll, or if you want automatic option, you can use this play button. Moreover, you can also make the cells living or dead while the simulation is running, as you can see here. This is great for fun activity. But if you seriously want to test out shapes, it's a better idea to make them in the stationary position or the post state of the simulation. Since there are quite a few practical applications of this concept, you can utilize this canvas and program to test out few shapes to some extent. For example, this is a still life pattern. It doesn't change during the course of simulation. And this is a glider pattern which translates across the canvas during simulation. And here is an oscillator pattern. As you can see here, it changes between two states in a finite number of steps. And this one is the most interesting, at least to me. It's called a lightweight spaceship. As you can see, it oscillates between two values, oppositions, and also travels along the simulation. It's even possible to create patterns which emulate logic gates and counters. Building up from these, it was proved that the game of life is Turing complete, which means that with a suitable initial pattern, one can do any computation that can be done on any computer. Later, Paul Rendell actually constructed a simple Turing machine as a proof of concept, which can be found on the internet. There are other programs like Life32 and Goalie which are heavily optimized and fully featured for the game of life. But as this program is just made for fun purposes, it serves its purpose well. And with this, I end my video, and I hope that you like this software. If you have anything to say, I would love to hear that in the comments below. And thanks for watching.